Chapter 4, SI Units and Measurements. The SI system has a base unit or a standard unit for every type of measurement. SI stands for Système International, which is French for International System. How chic! SI base units. Quantity measured, length or distance, is meters. Mass is grams. Weight or force, Newton. Volume or capacity, liter. Temperature, Kelvin. Time, seconds. Electric current, ampere. Amount of substrate, mole. Light intensity, candela. Because we want the SI units to describe both the distance around someone's bicep and the distance around Earth, we need to be able to change the size of a unit to fit the measurement. Scientists devised a system of prefixes that multiplies the base unit by factors of 10. Just by switching the prefix, an SI unit can be used for measurements big and small. So giga, mega, kilo, hecto, deca, then you have your base unit, which are meters, liters, or grams. Deci, centi, milli, micro, nano. 95% of the world uses SI units as the everyday system of measurement. SI unit conversions. Because the SI prefix system is based on the powers of 10, it is really easy to convert between units. If you are converting to a smaller unit of measurement, simply move the decimal point to the right as many places as the difference in place value. If you are converting to a larger unit of measurement, move the decimal point to the left as many places as the difference in place value. So for example, the base unit is 1 meter, and then we would have it's 0.001 kilometers or 100 centimeters. Same thing over here. Up here at the top, it has a mnemonic for SI prefixes. Great mighty King Henry died by drinking chunky milk Monday night. And that goes through all of them. The mnemonic that we learned in the video yesterday was a little bit different. So common sense. Remember to use the best fitting unit. If you measure the volume of the ocean with the same units you use to measure a glass of milk, the numbers would be very difficult to work with. The volume of the ocean should be measured using much larger units. Types of measurement. Length, the distance between 2 points. Volume, the amount of space something occupies. Mass, the amount of matter in a liquid, solid, or gas. Weight is the force exerted by a mass. When you measure someone's weight, you measure the force they exert on the earth. Mass and weight are not the same. Mass is the amount of matter in an object, and the weight is the force applied by a mass. Weight relies on gravity, which is a force, but mass doesn't. For example, the moon has less gravity than the Earth, so objects weigh less there than on Earth. Mass always remains the same. Weight changes. Density is the amount of matter in volume. Temperature, how hot or cold something is. While the SI unit for temperature is Kelvin, most scientists use the SI-derived unit Celsius to measure temperature. Then here we have the sink or float. Something denser will sink below something that is less dense. When oil is poured into liquid water, it floats on the surface of the water because oil is less dense than water. A stone sinks in water because it is denser than water. Water has a density of approximately 1.0. So oil's density must be less than 1, and a rock's density must be greater than 1. So don't get too caught up on this conversion. We're not going to be doing anything with converting temperatures, but it's just kind of neat to look at. So this is the formula to convert Celsius and Kelvin. So you have the different temperatures, and then depending on which way you go, it's either you add 273.15 or you subtract 273.15. In the US, we usually use Fahrenheit to measure temperature. This is the formula to convert Fahrenheit and Celsius. So it gives you the two formulas. Personally, I just look at a thermometer that has both of them on it. It's a lot easier. So there you just have the hot and the cold. The reason why they came up with Kelvin is because at absolute zero, molecules stop moving completely. This is not a temperature that we would find on Earth. This is a temperature that is in a lab because it is negative 459.67 degrees Fahrenheit. So we would not experience that on Earth. Time. The time between events, or how long something lasts. The SI unit for time is seconds. Other units for time include hours, days, months, and years. So here we have measurement tools. So distance. A meter stick, like a ruler, except it is 1 meter long, which is the equivalent of 100 centimeters. And it's a bit longer than a yardstick. A trundle wheel. To measure long distances, just roll the trundle wheel on the ground, and every time you walk a meter, the trundle wheel makes a clicking sound. Simple. Just remember to count the clicks. A tape measure. For measuring distances that would be hard to measure using a meter stick or a trundle wheel, such as a distance around a round object. Or if you're measuring things in your house, usually we use tape measures. They're easier. Volume. Graduated cylinder. A cylinder marked on the outside to indicate how much fluid it contains. Take your volume reading from the bottom of the meniscus and make sure you are taking the reading at eye level. The meniscus is the curved surface of a liquid in a tube. Volume of solids. To figure out the volume of a rectangular solid, simply measure its height, its width, and the length using any of the tools for measuring distance, and then multiply by 3. So volume equals length times width times height, which is why you would end up with cubic whatever. So the volume of irregular solids. The best way to measure the volume of an irregular solid is to place it in water and find the volume of water it displaces. The difference between the new and old volume measurements is equal to the volume of the object. Next time you get in a bath, look at the water you displace. That's your volume. Mass. Electronic balance. Just put the object on the pan and read the mass. Usually you need to tare it first, making sure that it's all at 0. These are the ones that we generally use in school now. A double pan balance. This compares the weight of objects in pans on each side of a balance. To find mass, place something of known mass in one pan, and the other pan place the object of unknown mass. When the pans are equal, the masses are equal. If you're measuring something that needs to be in a container, weigh the empty container on its own first, and then subtract the weight of the container afterwards. Triple beam balance. These are the ones that I used when I was in school. Works like a double balance pan, but instead of having a pan on each side of the balance, there's a pan on one side and 3 beams, each with sliding weights, called riders, on the other. Many doctors' offices use this still, and it's very accurate. Density. Because density is simply the amount of matter in a certain volume, you can calculate density by measuring the volume and mass of an object and dividing it like so. Density equals mass over volume. Time. To measure time, you can use a clock or a stopwatch. If you are using a regular clock, subtract the start time from the end time to figure out how much time has lapsed. Temperature. A thermometer. Used to measure temperature. A thermometer can be digital or it can be a liquid thermometer, which contains a liquid that changes volume with temperature. When taking temperature, make sure the bulb at the end of the thermometer is in the middle of the liquid you are measuring and not touching the sides or the bottom of the container. So check your knowledge. All right, number 1, what are the SI units for mass, length, and temperature? Number 2, what tool would you use to measure the height of your dog? Number 3, where would you look to take a volume reading of a liquid in a graduated cylinder? Number 4, what is the easiest tool used to measure mass? Number 5, how do you find the volume of a rectangular solid? Number 6, describe the difference between mass and weight. Number 7, convert 50 centimeters to kilometers. Number 8, define volume and list some common volumes measured. Number 9, if the boiling point of water in Celsius is 100 degrees, what is the boiling point in Kelvin? Number 10, you place a paper clip in a cup of soda and it sinks. What is denser, the paper clip or the soda? Would the paper clip most likely have a density of 2.8, 1.0, or 0.03 grams per milliliter? Go ahead, answer these questions. You can check your answers with the key that is posted and then submit.